Good afternoon. Welcome to the HBase presentation. This session was originally supposed to be done by our HBase expert, Xiaoming Guo, but unfortunately due to unavoidable logistical issues, he wasn't able to make it. So here I am, I'm Tilina. So Xiaoming is available online on the Jabber account. So if you guys have any questions, anything related to HBase, you can also ask from him. He'll be more than happy to answer. So this presentation also contains material from Xiaoming Guo, some material from Xiaoming Guo, as well as from Hui Li. In this presentation, we're going to look at what's HBase and what is the big table storage, and look at some sorry about that. Look at some HBase use cases and what's the difference between HBase versus a normal relational database system. And then at the end, we're going to do a very simple hands-on where we load a CSV file to HBase table using MapReduce. Yeah. The HBase, the idea is original from Google. So Google came up with this thing called Google Big Table. So the motivation behind that is Google had a lot of data, which are semi-structured and very, very large. So they wanted a storage system where they can do random reads and writes for this data, and as well as a system where they can have horizontal scalability. So horizontal scalability means to increase your power of your, increase the power and the efficiency of a system as when you add resources proportionally. So, and then the other thing they wanted is for this system to run on top of commodity hardware and to have some tight integration with MapReduce so that they can process this data stored on big table using MapReduce. And the other reason is the traditional normal relational database systems. I mean, I'm referring to things like MySQL. So they don't really scale into this level. I mean, if you want to go to hundreds of nodes, that's almost impossible. And there are some systems where you can do that, but then it's going to cost you a ton of money. So the original idea is from Google. It's called Big Table, and I have a link to the paper. So if you guys want to know any internal details and more detailed idea about the motivation and the technologies behind this, you should go ahead and read that paper. So Apache HBase. So Apache HBase is an open source distributed column-oriented data store, which supports storing very large amounts of data, storing as well as processing very large amount of data using commodity hardware. So HBase is distributed because it supports storing this data across the nodes and then as well as processing those data on those nodes. And when you talk about these nodes, these are just commodity nodes which are interconnected using normal GigE or normal network interconnects. And then this project is open source, so it's contributed. It has a very vibrant community around it, and it's been, I mean, people are contributing from all over the world, and hundreds of companies are investing on it. So if you decide to use HBase, you can get the advantage of this collective intelligence from all these people. So the HBase is ideal if you want to do random and real-time read and write access to your big data. I mean, if you don't need random read and write access, then you can, I mean, you can just do it normal Hadoop HDFS, which supports sequential reads. But the good thing about HBase is you can do these real-time random reads and writes. And then if you have, so HBase is really good in hosting very large amount of data. So when you talk about these tables in HBase, we are talking about billions of rows and millions of columns in that scale, and then distributed across hundreds of instances. Yeah, and then HBase supports automatic partitioning of data. So you don't need to worry about if a certain region or a certain table gets very large, I mean, whether you're going to run out of space, because HBase will automatically take care of moving the things around and distributing the load across the cluster and distributing the storage resources across the cluster. So this is the point I mentioned even earlier, the linear scalability. So if you have HBase cluster, for example, let's think of if you have 10 nodes with a single disk on it, and you have HBase running, and then you decide to add one more disk per node. So this effectively doubles your storage capacity. And then and for the next step, let's think you decide to add 10 more similar nodes to your cluster. So this essentially doubles your storage capacity as well as your processing capacity. So that's the linear scalability we are talking about. What's the relationship between HBase and Hadoop? So HBase was essentially built on top of Hadoop, and HBase uses the Hadoop distributed file system to store the data. So because of that, it automatically gains the advantages like fault tolerance and the scalability that you have in Hadoop distributed file system. So one major advantage on top of using just HDFS is that HDFS adds the support to do random reads and writes, which is not possible with Hadoop distributed file system, which only supports sequential writes and sequential reads. So another main advantage of HBase is the ability to process this very large amount of very large tables that are stored in HBase using Hadoop MapReduce. When to use HBase? So especially when you have very large data, and when you're talking about these data scales, we're talking about hundreds of gigabytes. So if your data can fit into a single machine, a single node, a single fat node, and can be put into a single RDBMS, then it's probably not a good idea to go ahead with HBase. But then on the other hand, if your data has the potential to go to hundreds of gigabytes, terabytes, or even up to a petabyte, then HBase would be an ideal candidate to use. And then the other thing is it's normally considered, it's not, you should at least have around 5 nodes to get the maximum out of HBase. So if you're going to go deploy HBase cluster with less than 5 nodes, the advantages you might get would be far less than having more than 5 nodes. This is just a rough number. And the other thing is HBase supports high throughput reads and writes. So if your application needs to do thousands or tens of thousands or even more than that reads or writes per second, then HBase is a very good choice, because HBase distributes these writes and reads across nodes. So if a node can do thousands of 1,000 reads or 1,000 writes per second, then if you have 100 nodes, it's you automatically get 100,000 writes and reads per second throughput for your storage system. So that would be an ideal scenario use case to use HBase. The other thing is, if you want to do this batch analysis, like doing MapReduce computations and doing these data mining computations on top of the data stored in HBase periodically, in that case would be ideal scenario to do to use HBase. And when we say perform MapReduce computations on top of HBase, it's going to execute parallelly in the nodes where the data is actually stored. So you get that advantage as well. The other advantage is you get a large cache. For example, if you're using 10 nodes and each node has, let's say, 50 gigabytes of RAM, then your collective amount of cache, the memory available for caching, goes up to 500 gigabytes. And then this can, as you increase the nodes and the memory capacity of your nodes, this scales. So you can get very good performance benefits by using this distributed cache. The other thing HBase is good is if you have sparse data. So the normal relational database systems and the traditional databases are not really designed for sparse data or are really efficient with sparse data. So, but in case if you're using HBase, you don't really get any hit, any performance or storage hit because of the usage of sparse data. So in the next slides, we're going to look at how HBase actually stores the data. So in there, it will become much more clear why it's good for storing sparse data.